Good morning. Thank you for the time and opportunity given to me. On this occasion, I will present the results of my research with the title Mathematical Model of the Spread of African Swine Fever Disease and its Numerical Solutions based on the Fourth Order Runge-Kutta and the Milne methods by Maria Yasinta Bhoki and Sudi Mungkasi. The first part begins with an introduction. Definition of African swine fever. African swine fever, or ASF, is a disease in pigs that is highly contagious and can cause death in pigs up to 90%, resulting in huge economic losses. Causes of African swine fever. ASF is caused by a DNA virus with double strands of the genus Asfivirus and the family Asfarviridae. Clinical sign of African swine fever infection. Redness of the abdomen and chest, bloody diarrhea, redness of the ears, fever in 41 degrees Celsius, constipation, sinuses, skin bleeding. The pig becomes depressed, recumbent, has difficulty breathing, and does not want to eat. Spread and transmission of African swine fever. ASF disease can be transmitted if it comes into contact with a sick pig through the blood, body fluids, and tissues of an infected pig because it contains a high concentration of the virus. Transmission can also occur through equipment, feed, and beverages contaminated with the virus. In addition, contagion can also occur through the bite of a tick that acts as a biological vector of the ASF virus. Prevention and control of African swine fever. To date, no vaccine has been found for the prevention of ASF disease. Therefore, the main strategic step in preventing the spread of ASF is through the implementation of good biosecurity and management of pig farms, as well as strict and intensive supervision for high-risk areas. Now we enter in the second part, which is mathematical model. The development of science in the field of mathematics also has an important role to be able to control the spread of this ASF disease, namely by applying mathematical modeling. In this study, it will be discussed about mathematical modeling of the spread of ASF disease with the Crc model. The mathematical model used consists of SP, IP, RP, ST, which describes the dynamics of the spread of ASF disease. The population is divided into several parts, namely pigs susceptible to disease or SP, infected pigs or IP, recovered pigs or RP, pigs that are susceptible to disease or ST, and infected pigs or IT. A graphical representation of the proposed model is shown in Figure 1. Here is a ASF disease spread model diagram. Based on the image given in the previous slide, a Crc mathematical model will be created, namely, as shown on the slide. Description of variables and parameters are given in Table 1. The completion of the Crc model will find a solution by comparing the error value and the accuracy rate of the fourth-order Runge-Kutta method and the Milne method. 1. Fourth-order Runge-Kutta method. The fourth-order Runge-Kutta method is a numerical method often used to solve differential equation. Based on the expansion of the function of the Taylor series, the fourth-order Runge-Kutta method has a minimum of cutting errors, resulting in a good solution. 2. Milne method. Milne method is a multi-step method consisting for a predictor and a corrector to find a solution to a given initial value problem. Now we go into the third part, which is data analysis. This section contains simulation results based on the numerical sum of the fourth-order Runge-Kutta method and the numerical sum of the Milne method. Numerical programming and simulation are performed using MATLAB software. For all numerical simulation, the initial values and parameter values are presented in Table 2. Simulation results of the fourth-order Runge-Kutta and Milne methods. Figure 2 provides the behavior of the spread of ASF disease with the Crc model using the fourth-order Runge-Kutta method. From the graph obtained, it can be seen that the magnitude of the SP, that is, the population of pigs susceptible to the disease, increases over time. The population of IP, that is, the population of pigs infected with the disease, has decreased. The population of RP, that is, the population of pigs recovering from the disease, increases and then decreases over time. The population of ST, namely the population of ticks that are susceptible to disease, has decreased over time. The latter is the population of IT, that is, the population of ticks infected with the disease decreases over time. Towards the end of the period, the population of SP increased slowly, responding to the population of IP, RP, ST, and IT that fell asymptotically towards zero. The results of simulating the spread of ASF disease with the Crc model using the Milne method are shown in Figure 3. The acquisition of a solution graph using the Milne method is similar to the pattern of spreading the results of the fourth-order Runge-Kutta method. The behavior is the same. Calculating the error and accuracy level of fourth-order Runge-Kutta and Milne method. In order to prove which method is the most accurate among the fourth-order Runge-Kutta method and the Milne method in the spread of ASF disease, the error and accuracy of these two methods must be measured. The reference solution used is the ODE45 algorithm in MATLAB. The following is a comparison of the average error value between the fourth-order Runge-Kutta and the Milne methods. It can be seen that the average error of the fourth-order Runge-Kutta method is smaller than the average error of the Milne method. The following is a comparison of the degree of accuracy between the fourth-order Runge-Kutta and the Milne methods. It can be seen that the accuracy rate of the fourth-order Runge-Kutta method equals to the accuracy rate of the Milne method. We come to the last stage, which is the conclusion. The calculation results show that the average error of the fourth-order Runge-Kutta method is smaller than that of the Milne method, and the accuracy rate of the fourth-order Runge-Kutta method is equal to the accuracy level of the Milne method. Therefore, it can be concluded that the fourth-order Runge-Kutta method is more effective when compared with the Milne method in its application to solve the Crc model of the spread of ASF disease. Thank you.